All right, for this lesson, we're going to be using a worksheet. So you're going to take the worksheet. Sorry, I accidentally did it backwards, but you're going to fold it in half so that types of numbers is on the front. This is on operations of real numbers. We are actually going to talk about the basics right now, and then the operation part we will talk about in class. So starting with all the different types of numbers. So natural numbers are all whole numbers greater than 0. So you can't use 0, you can't use negatives. Whole numbers, that is the same as natural plus 0. So you start with 0 and then 1, 2, 3, 4, 5, 6, 7, so forth. And then we have integer. That's going to be every whole number. So negatives, 0, and positives. And then rational numbers. This is one of the big things that we're talking about, operations on rational numbers and irrational numbers. So rational numbers can be expressed in the form of a over b. So ultimately, if it can be expressed as a fraction, then it's a rational number. Irrational is not on here, so I'm going to have you guys write it on the side, but that's like the other thing that we talk about. So irrational. Okay, so it's the opposite of rational. Rational can be written as a fraction. Irrational cannot be written as a fraction. So we'll go over examples of that. And then all of these numbers, natural, whole number, integer, rational, irrational, they're all considered real numbers. Okay, and then to show you some examples of these vocab terms, you don't need to do this, just if you want to look. These are some examples of rational numbers, so things that can be written as a fraction or a whole number either way, because over 1 is still a fraction. And then integers, anything that is a negative whole number or 0 or a positive whole number. And then whole numbers, 0 through all the positives, and then natural numbers, all the positives, no 0, no negatives. And then irrational, there's some very specific irrational numbers like e and square root of 3, square root of 2, pi. These are the most popular 3 irrational numbers. And then a number that keeps going on and on and on, doesn't repeat or anything like that. And we'll go over that a little bit more here in a second. So that's the vocab. And then let's go ahead and talk about on the back, nope, not the back side, inside, irrational numbers. So irrational numbers are numbers that cannot be written as a ratio of 2 integers. So no fractions. That's what we were talking about. The square root of a non-perfect square is non-repeating and non-terminating. So repeating would be like if it had the line on the top of it, that meant it's repeating. It can't repeat to be irrational. So non-repeating, and then non-terminating. So it's not like 1.3458 and then stops. It can't do that. It has to be a dot, 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 dot. Okay. So also a little hint here, any one of these that can't simplify. Okay, so any radical that can't simplify is going to be considered irrational. Okay, if a decimal is non-repeating and non-terminating, it is an irrational number. I feel like that's a repeat there. And then some examples. So we talked about pi, we talked about e, we talked about the square root of 2, square root of 3. A non-terminating would be something like 3.8965 dot dot dot. So there's no pattern happening, and then there's the dot dot dot. So it's not repeating and it's non-terminating. So that's why it is considered irrational. And something like 30, the square root of 35, that's just 7 times 5, so we can't simplify that anymore. So that would be considered irrational as well. Okay, on to the other side. You guys know these are ready, so just real quick, proper fractions, something like 1/2 or 3/4. Improper fraction is where the number's bigger on the top, so 12/5, 5/4, anything like that. Mixed number, that's when you have a big number, a whole number in the front. Integers, so we can have a negative number, we can have 0, we can have a positive number. Repeating decimals, that would be something like this, 0.2121, and then dot, dot, dot. Since it's the same pattern, that's repeating over and over again. Or you could have something like this, where it has the line over, and that represents repeating as well. Terminating decimals, that would be like 0.25, and then there's no dot, dot, dot. It stops. That's what terminate means, right? Those are some more examples. All right, so a terminating decimal is a decimal, there we go, with a finite number of decimal places. A repeating decimal is a decimal with, I think that's supposed to say 1. 1 or more digits that repeat without limits. Okay, and then the last one is going to be coloring examples of irrational and rational, and I'll have you guys do this on your own, but I'm going to show you a few real fast. So let's see. The number, color it green if it's rational. So a few examples of rational, remember, is anything that can be written as a fraction. So 5 can be written as 5/1, so that's good. The square root of 9 can be written as 3, right, which is 3/1, so that's a good example. Let's see another one. 1/8, there's a good example. 2 to the 5th power, that's a good example, and you guys can fill in the rest. If it's irrational, you're going to do yellow, so something like this where it's not repeating and it's non-terminating. 432, pi, that's one of our popular ones. And then I'm going to let you guys go over the rest. So any that are like this, you need to simplify it and see if it can simplify. If it's a perfect square, then it's going to be rational. If it's not, like if it has leftovers, per se, like this one, because when you do it, you're going to get 4 square root 2. Doesn't matter if there's a whole number out front. There's still a square root right here that can't be simplified, which means it's irrational. Okay? All right, we're going to go in depth about the operations of rational and irrational in class. So finish the rest of this.